Yeah, hi guys. Today in today's video, we're gonna be what's it called? We're gonna be writing a smart contract for to-do list. Um, so let's quickly start. I think we started it already. Now, the first thing we do into when we're talking about to-do list, what we actually gonna be doing, the first thing we're gonna do as a to-do list is to use what we call tasks. Then to create a task, then after creating the tags, so the tags we created, we need to, like, you all know how to do this work now. Like, you have to put the, like, for example, you want to read twice, you want, like, the event or the tags you want to do for the day, like, you have to list it out and put it in one of your book, right? Then keep, whenever, once you are done with it, you mark, you take it out. Okay, I'm done with this particular task. Okay, for example, I want to cook rice, I want to wash plates, I want to go to the market, I want to, I want to sleep, or I want to eat, or let's say, yeah, I want to eat. So let's say these are the five tasks we have, you know. So, like, listing them out, putting them in a particular place, that you have to write it down. As an organized someone, you have to add something like that. So once you, what's it called? Once you finish with one, you have to mark it out. Yeah, I'm done with this today. I'm done with this one. I'm done with this, and I'm done with this particular one. You get? So that's the same thing. This particular thing now. That's what we want to build as an application on our blockchain. So if you want to build something like that on our blockchain, what are the things we need now? We need to know that, okay, we have to have the tax as an object itself. Then now try to create it. Then you toggle it, you update it, and you also delete it. So I was now, if we want to do the first thing we want to be doing is to create what we call a struct. Now, why are we using struct? Why are we not using variable instead of, why are we not using variable? Why is it that it's struct we are using? The reason why we are using struct is this. Struct is just like a form of variable that stores more than one value, unlike what's it called, like variable in Solidity. In Solidity now, variable can only store one value. For example, like this now, with this variable we declare, this tax we declare here, the only thing that it will be accepting, it will be storing, is only string. You get? But we using struct will give us more access to store more than one data type. You get? You're gonna store, you can store bool, you can store string together with what's it called, with uint. You get? So, and the tags we want to be using, we are not only using string alone. We want to use both string, integers, and all those stuff like that, to to get what's it called, to get this guy, to get the what's it called, to map the tags we want to use. So that's why the first step is you have to use struct. So we create a struct, then we'll give it the name. The name of our struct is SAS. So struct in short term is just like a it's just like an object. You get? Like an object that are, now what we use objects for. So like an object where you list the part of the component of those objects, the things that derive the properties of those objects. So that's actually what we want to be doing. So so let's quickly jump into it. Now the first struct we'll be creating is for the tasks, right? So what are the things we need? What are the properties we need? The first property we need is uint in 256. That is an IDs that identifies each task that has been created. You get? Sorry, uint, not unit. Then the next one we're gonna be using, the next what is it called? The next thing we're going to be doing is the content itself. That is, whenever you want to maybe writing out what you want to do, like I want to write like cooking rice and the like. So this is how to do it. You declare the string too. So let's just call this content. Then the next thing we're gonna be doing, so it's giving us red line because of this. Yeah, the next thing I'm gonna be doing is to create what is it called? After you've written the content that you want to add it, you'll be able to add, right? So we want to create a booth for it. So to tell us that, okay, I've completed what is it called, this particular task. Like if you are done with the task, we want to have a boolean that will let us know that true, this task has been completed or it has not been completed. So all these will be inside a task. So whenever you want to do what's it called? Okay, I think we're gonna be using this. Yeah, we're gonna be using that. It's not, you don't have to, it doesn't have it. There are separate data types on their own. You get separate data types on their own, so they have to stand alone. So we have the first property, an ID. That there will be a unique ID for each task. Don't forget, why the content you are writing for the task, and if the task has been completed. So that's the object. So here now you'll be able to create what's it called, a struct, an object for our task. Now, having created the object, the next thing we're going to be doing is to create what's it called, a counter. You get, that we help us to generate unique ID. You get, so we have to create a counter. Then we just, how do we create a counter? We use the counter. We're gonna is gonna be, what's it called, it's gonna be a uint. So we have a uint 256. Then we call it task counter. Yeah. So this task counter is gonna have a we're gonna have a visibility called public. So this task counter, what is going to be, is going to help us to calculate, like to like show the unique, to identify to generate the unique ID for our tax, or the unique ID tax. You're going to generate it for us, like keep generating. For example, if you add a one particular task, you're going to give it a particular ID. If you generate this particular, if you generated this, the other one, you're going to give it another ID. It's going to be like listing it, helping us to list it accordingly. So that's what this particular task is doing. And the next thing we're going to do is to what's it called? To like, don't forget, we have a unique ID already, which is an ID, right? And the next thing is to map, to use mapping. You get now. So to map our, what's it called, the unique ID, the tax ID, to each of the what's it called, each of the IDs, each of the tax. Like the ID of the tax is to map it together, to store. Let me write it first so that I will explain. The first thing is to write this. Then the next one is 256, is to map our task. Then we're declaring the variable. We can call it public. Then we give it a name. What's the name? So you can just give it a crypto letter. Yeah, task. Just monitor. So here, what's this mapping doing? What this mapping is doing is mapping this our task, this particular, this one is not generating the UINs, right? It's not generating the unique ID. So we use this, it to keep track of all these guy here. So each task you added, it's going to have unique ID. Then it's going to keep track of these guys. Okay, so that's what this particular variable is doing. It's like keeping track of, how we keep track of balance. You get now. So how you keep track of balance from maybe if you're writing a normal smart contract. So that's just the same thing this guy is doing. So having done all this, the next thing we're going to be doing is to create what we call an event. So what does event does? What events we just do for you? Whenever you create what's it called? When you create any of the tasks, you're going to notify users. So this particular one is kind of useful in the front end. Whenever I want to write the front end, whenever you click on create, and it's going to pop up to show the user that okay, oh, the event has been created, your what's it called, your task has been created. You get, so all this stuff now, if you want to do it on blockchain, for it to notify you whatever, whenever the new event is this is how you use it. Yeah, so we're gonna declare the keyword for event, then we say task created. Yeah, so task created. Then what are the things that will be in the task? The first thing we're gonna have is in 256. Then what was it called? Or wait, let's not do this first. We'll come back to this. Let's not do this. Let's quickly go to creating of what's it called? Create task. Let's quickly go to the function first. We'll come back to this. So create task function. Let's start with that. Since we have the struct already, an object for, or the objects you want to create. If you want to create something, you need to have the object at hand. Let me explain it in this scenario so that you understand it. For example, you want to create something. Maybe you want to create let's just say, like for instance, someone want to build house. Before you can build the house, what will it be the first thing you have to do? You need to have all those equipment, right? You need to buy all those equipment at hand. Yes, so that's actually what's happening here. So you have created the object itself. Now we have bought our all our equipment we need, which is this. Now the next one is to now start creating. So how do we create a task? How do we create a task? So the first thing we're going to be doing is to write our function. Then after having written that, then you can give it the function name, which is create task. So how do we create, if you want to create a task, then we have something inside. Like, you have to put in something inside your task, right? Like you have to put in the name, what's it called? Like you want to cook rice, right? So you have to write the rice, write it in the word, right? So for us to do that, we need to use string memory. Then we use contents. Yeah, contents. So we use contents. So you get, so content. So the content is going to be, you're gonna have it like, because we have one content which is inside the main task itself. So then the next one is to give the visibility of your contract. Then let's now define the logic for creating the task. Now the first thing to do is to set our counter to increase, right? Set our counter to increase. Yeah. So we have to set our counter, that's a task counter. We have to increase it. Now, before we increase it, we need to initialize it to 0 first. And now you want to use a counter in a smart contract, you need to initialize it to 0. So this is what will bring about what we call a constructor. So what we can use to do that is constructor. So we just create a constructor. So that constructor is going to be the one to initialize our counter. initialize the count. So and constructor runs just once in a what's it called? Constructor runs once in a smart contract. So yeah, we are having the okay, is not there's not an error, right? Let me just put the public there so that it should not throw us error. Okay, let's leave the public there. I think version 0.8 doesn't require, but what's it called? Does not require visibility. So having done this, we've used this to initialize the counter. Then this we use it to increase whenever you. So what this is actually doing is whenever you add any content, this guy will be the one to keep adding it, like keep adding it. If you add 10, it's really want to be like mapping the right thing, you get. So that's actually what that guy is doing. So the next thing we're gonna be doing is to is to use our struct to create what's it called to store the what's it called this guy to store this guy to store these guys to store them inside here. You know, this is the storage itself. This is the storage itself. There are different ways you can hide this. You can hide this another way. If you don't want to use map, you can just use normal dot push, the way we did the simple storage stuff. But let's just use this method this time since we've used that one in that particular place. So let's use it. So we want to be storing each of our task inside here. So how do we do that? How do we do that? So this is how we do it. We call the task itself. Then, since we are mapping it with something, we are mapping it with task count, right? Am I right? Yes, we're mapping it with what is it called? Task count. So we're gonna use task counter. Yeah, so your task counter rather. So we use it. We're mapping it with a task counter. Yeah, you know now. Don't forget the task counter itself. This is the value here. So is the one that is going to is the one, you know, is the one that is generating the unique ID. So we are using the unique ID should be equals to then our tax itself, which is this guy tax, then the tax. So the tax now we have tax counter, comma, then we have what the next thing we want to do there. So we have the contents, then we have, so for now, since we have not complete, we started with false, right? So with this, with this now, we've been able to store our function. This is what it's doing. This is this particular one, which is a task counter. Don't forget, this is it here. Is the one that is storing, is the one that we will use to map the whatever tags we put in. So these are the tags we want to put in. So it's mapping this tags. This is the storage, right? This storage now is the one what's it called? This is the unique ID that this guy is generating, right? After generating the unique ID, so we now use the unique ID to map whatever what's it called, information that is being given here. So one of the things that we need to know in our tags is what is the unique IDs of the tags, then the content the person puts, and is it completed or not. So for now, at default, it should be as what should be at this thing should be false. So whenever you are not done with it, then that's when you see what it should now change to true. Again, so what this particular one is actually doing, you all know is doing is like it's one whenever you keep adding, is one that will be arranging it in an order. Why we use this itself, this logic itself to create the tax itself. You get, so it's easy to create the tax itself. So that's how this work. Yeah. So with this, I think we're done with creating our task. So we've been able to create our task with this. So the next thing we're gonna be doing after creating the task, now let's create the toggle function too. So this is just how to create your task. Then the next one is to create a toggle function. So we use a function. Then yeah, we'll call it toggle tasks. Let me write it one after the other so that you can understand. Then we create the function name. This is the function name for the tag. If you want to create a function name, then having done that, the next thing we're gonna be doing is to toggle, like, well, don't forget, we need to understand what will be inside this, what will be the argument for this toggle task. Since we want to toggle, like we want to see the what they call the content, the one that has how do I want to put it, the one that has particular unique ID that has particular task, right? So like just a form of, let's just use it in a form of search. It's just more of like search, right? So to know that is this task completed or not, you get. So that's what this, to ensure that the task is completed or not. So if we want to do that, something like that, we need to have our declare our ID, then underscores, sorry, 256, then underscores task ID. So yeah, so with this you can give the public because we want everyone to access, everyone can access it, you get, want everyone to access it. Then the next thing we're going to be doing is now to store it, you get, to store it, you get. So to toggle the configuration, so want to store it, let's store. So how do we do it? We say task, then we give it a storage. So these are, yeah, so there's a difference between storage, memory, and core data. So what memory just does is that we use memory for what's it called, for a data you want to store temporarily, you get. But we use this guy, we use storage for a data you are storing permanently on the blockchain. Then while we use core data for storing permanently as well. So but what's the difference between storage and core data? Core data is kind of more less what's it called, less gas optimization. When it comes to gas optimization, like to optimize our gas. So that's what we actually use core data for, you get. But they are still the same thing with storage. It's just that storage is kind of consume data a lot, you get. So that's just it for by that. So you can also read more about storage. And now let's use this to declare what we call a task. Then having gotten this, the next thing is to have our tasks. Yeah, so this is it. So with this, we've been able to write what's it called? Be able to, like, to be able to search for the unique ID, to toggle for unique ID of our smart contract. You get, of our task rather. You get. So with this, we can be able to search for it. So let me see. All the name we given to our yeah, it's stack. So you're right. Yeah, so that's the first thing. Now the next thing is to check if this guy is to know if to get what's it called, to know if this guy has been if the task has been completed or not, you get, if the task has been completed or not. So how do we do that? We just say task dot completed. Is it completed we use? So which is equals to, let me see, yeah, completed. So we use completed is equals to something. What is it going to be equals to? So it's going to be equals to is task is not equals to completed. Yeah, so this is it. So task is what is it called? Task. Sorry, it's not task, it's task. This one, this guy here. So it's going to be task dot completed equals to task is not completed. Is task not completed? So yep. So with this, we can toggle this guy. We can toggle our smart contract. We can toggle our smart contract to know. So what is actually doing is to know if what they call, if the particular unique ID we are searching for, the task has been completed or not. That's actually what the toggle or what they call is doing. Also let us know if particular task we are doing, we are on is completed or not. Again, maybe we have you completed it. So that's actually what this guy is doing. So with this, I think we're done with our toggle. We're not done yet because there's something we're saying about. Let's just focus more on how to write the function first. Then before we move on to how to. Now the next thing we want to do, we want to write the function that we update whatever, maybe we update our task, you get. So we have a update task. So once we update our task, so use this, then yeah, so if we want to update our task, what will be the arguments we're going to be putting there? So the argument that is mapping our task is what? The argument that is mapping our task is what? So the argument that is mapping our task is what is it called? The task ID itself and the content in it. You get a task ID and the content in it. So with our task ID, then we have our uint 256, which is a task ID. Then what's it called? Yeah, those are the things we have to change now. Those are the things we like not changing. Like, for example, you want to update this what you've created already, like the task one. Now the first thing is to first write out the one, now that it is. Don't forget, we need to remember that when we want to store this guy here, this is storage. Don't forget, this mapping is a storage. So we are storing how does it go? We are whatever we are storing here, all each task is being stored, is being mapped by this guy. Is keeping track. This unique ID is one that is helping us to keep track of the task. So each task, for example, I want to cook rice. Cooking rice now is one task, right? So there will be a unique ID for it. So this before if you don't want to update when you've created after you've created your task with this function, you get now, and you want to that task, and maybe that cooking rice, I want to change it to cooking beans, you get, you will need the unique ID. We have a lot of tasks. So you want particular one you want to change, you need you need an ID for it, right? Don't forget, each of the tasks is being created with what? Like it's been assigned to a particular unique ID. So for you to now update, you will need the particular ID to know, so that the what they call the blockchain will tell you this is the smart contract will tell you that okay, this is a particular one you want to update. So that's when you have to put the task ID. Then after the task ID, the next thing you're gonna be putting is the contents, then which is the contents you want to create. You want to change it to from one cooking rice to cooking rice. to cooking beans. So we have to change the content. So that's why we are using memory. So we're using memory. Don't forget, we all have explained why we use memory. We use memory because this guy is not stored in the this guy is not stored on blockchain permanently. It's just storing temporarily. You get, unlike this guy here, this storage here, this one now, we know that this particular task here is a permanent storage already. You get, we use to use a permanent storage. So that's why we use contents there. That's why we use storage there. So here we're gonna have our public down. Yeah, let's see how do we now write the logic to update our what is it called? To update our contract. To update our so just the same thing, almost the same thing with this guy. The first thing is to write our task, then storage, then task 2, then which is equals to then our mapping. This guy that is mapping the unique ID generated. Yeah, cool. That's the first thing. Yeah. The second thing is to check if there is a content already. So which is task.content. Yeah, where is it coming from? From our main task, right? So which is equals to, there is content, yes, there's a content. Now then that content will now be equals to whatever content that has been put here, this guy here, whatever content. So our tax.content, the value of the tax.content should be the value of this content that we are using to update our contract. So this is how to update our contract, just simple as that. Now let's look at the last task we are be given. So the last task is to delete. So how do we delete? So we start with delete task, right? So we use delete task. Then so we want to delete tasks. Now, what are necessary things we need to delete our tasks? All we just need to delete tasks is just the unique ID that is mapping our what? That is keeping track of our struct, that is the tax itself, that's keeping track of the tax itself, which is the struct, right? The object of the tax. So that's the only thing we need. Now let's write a logic for how do we delete our tags. So simple and easy. Just the same way, we need to show the storage, then tell that is a storage, create a storage, then which is equals to normal, the way we normally do it, the map, this map that's keeping track of our guy here, which is the unique ID. Then we use the keyword delete. There's a keyword for what's it called in a smart contract that's called delete. We just use delete. Then we now use task, that is the storage itself, gone. Then the storage itself, then with the unique ID that has been stored there. So whatever unique ID I've put here, so you should delete it. Delete this. This is from this storage. Don't forget, this tax is a storage. We all know that. The tax is a storage. Sorry. Yeah, this tax is a storage. Sorry. Yeah, so let me just come down here. Yeah, this tax itself is a storage. Yeah, tax, what's it called? Storage tax equals to this is the storage itself, and keeping track of the storage. Then we want to delete the tax ID, any of the tax ID that has been mapped. Okay, so that's how this guy works. So that's just it. That's just it. We've created a smart contract now, but we are not done yet. We need to create an event for each of the function in order to notify the user that okay, you have successfully deleted this so notify that the task has been executed. So yeah, so the first event we are creating is what is it called, to create a task creation, like create task function. So it needs to have an event, so they will go which to update guys that okay, task has been created successfully. So we use task. Then in our task function there will be like value. The first thing that will be there in 256, so ID, you get, so it's going to be a task ID. It's going to be a task ID. Then we're going to have another one. We're going to have a string. We're going to have a string, which is the content, right? Then the next one is maybe it has completed or not. So 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 our object, which is the task, so for us to be indexed, you need to use indexed. So this is actually meant for the front end though. So it's going to help you to, you can use what we call a subgraph to index these guys, to update, so that you can update what's it called, guys, whenever they use the Todolist app. You get? So there's a way we indexed it, which should be that's an advanced class, sorry. So that's the first one. Now that's for creating an event. So we need to write a task for updating an event too. Sorry, updating a task and deleting a task as well. So the same thing in create and update of a task, just the same thing. So it's just the name that will change. So we have events, then update the task, sorry, yeah, update task, just the same thing, just the same thing. Then pull our bool, yeah. So that's just it. Yeah, the next one is to what's it called, delete. Let's create a delete task events too. A task events. So these task events will only involve only the task ID. So that's so with this we've created an event. The next thing we're gonna be doing is now to emit. You need to emit the events in each of those functions. You guys, we need to emit our events in each of our functions. So for the task created, so we need to emit the event. So this we what emit function, you can read more on emit function. So what emit function will just do, what emit will just do is that the event you've created is going to like push it out. That's basically what is all about emit, you get. So that's basically what it does. That's basically what it does. It's just what they call. So this is this guy here. This one that needs to be here. So these two is the value you are putting, not the variable anymore. So the value just should be false. So this tax ID, what should the tax ID be? Yeah, the tax ID will be this guy. The tax ID will be the tax count, the tax counter rather. So it's going to be the tax counter. Now the counter is one that is, if you're adding more, it's one that is giving you access to add more to this. So the toggle, whatever doesn't need an event. So while the updates, we use our updates as usual. So sorry, I'm gonna give it a name. What's the name? Update task, right? Yeah. So this is gonna be having the contents too. This guy here. Then gonna be having tax ID. Then here we're gonna be having um that's going to be what's it called to? That's gonna be this guy. Yeah, so that's gonna be tax dot completed, because that's this guy's guy. So it's gonna be task dot completed. Yep, yep, I think this is it. Yeah, so yeah, so for delete what's it called? Delete events, you need to emit his own events which you created. So you call the events to delete tasks. So that's going to be small letter. Yeah, so yeah, that's just it. With this contract, you can use this and it's gonna work. You compile and we run the contract, it should work. We can also deploy the contract as well. So we're gonna deploy the contract and we look for to test it later on. You guys, we're gonna test it later on. Let's check. Are we missing out anything? Let's check. Are we missing out anything before I run it? Okay, yeah. So another thing we need to do as well is to emit an event here too. So we emit update task here as well. So we're gonna have underscores IDs, and we're gonna have underscores contents. Then this will be task dot completed. So the task, the storage, what they call, that's completed, and this. Oh, I think this should be also task dot content. Yeah. So task dot content. So we are missing the event of what they call the task. This guy, the toggle task. We are missing the events too. So I think with this, we don't have any other thing we're doing. Let me check here. So our task here, sorry. So let's quickly run our contract. So we're done with the contract. Okay, yeah, let's recap what we've done. Let's explain it again. Now, what we're trying to build is a to-do list. So the to-do list, all know that in a to-do list, the first thing we need to, the main thing in to-do list is to um like a task, right? To write down your tasks and try to complete each of the tasks you've written down maybe in a day, right? So now, for us to know that, the first thing we need to do is to create a like an object for that your task, which is this that we've created. You get for example, I make use of an example of like someone who wants to build an house. You need to have your equipment already at hand, your blocks, whatever. You have mixed all those stuff together, right? Both block, you're not using only one thing now. You're using more than two things. Using blocks, you're using what's it called? We're using water, we're using cement and all those stuff now. So getting it down is the same thing as this guy here. Now we now start creating. Now, yeah, so we now use this variable here, task counter. What this variable is actually doing is to how do I want to put it? Is to make your project what do you call, is like like to generate a unique ID for you. So it's not generating a unique ID for you. That's why you are giving it was you in 256. Then that will be generating unique ID in each of your tasks. For example, you want to cook rice, as I said. For example, I want to cook rice. Look, these are the tasks. Let's say these are the tasks now. This list of the tasks. Cooking rice, cooking rice, going going to the market. Oh, sorry. Let me just remove this guy. Yeah, I don't need you now. Now I see or something. So okay, let me give each of them. Let's say these are the tasks we want to put in our app. Cooking rice, going to market, you know, visiting or just sleeping, sleep. Then we want to let's use this three for now. So this three of each of these guys now, whenever you want to put it in your to-do list app, there will be an what is it called, will be assigned to them. A unique ID will be assigned to them for our blockchain to understand them, to understand it that okay, unique ID will be assigned to each of these tasks. Yes, these tasks now, each of them, unique ID will be assigned to each of them. Now let's say you've now what's it called? So this content you are putting there, you have to put a content there. So this task now, that's how you now create a task. You create a body that house this is the ID that will be generated, then the content which is cooking rice, and also is it completed or no? Have you done that task or not? So these are the three parts, let's say component of the task that we want to create on our app. You get. So if, for example, you are done with this task now, we want what's it called? So yeah, so these are the tasks, right? And I've explained that these are the parts, these are the component of our task. That is, we should have an ID, that's an identifier to identify that okay, this particular task, maybe our cooking rice is kind of stored in this place, while this one going to market is another task that we have his own unique ID. It gets to identify okay, this is what they call, for now this particular one now, we have an ID, it has a content, and it's more there are three things that this cooking rice condition needs to meet. It needs to We need to have an ID for it in order to identify it. If we have more than 100 tags, you get to understand that okay, this is particular task I want to do. You get. While the second one is the content itself. So this one too is just to also identify that okay, to know that okay, this is actually task I want to carry on. Why bool, which is completed, what is it called? Bool completed. This part, this one is now to tell us, is that what's it called? Has that particular task been what's it called? Being carried out? Yeah. So that's what actually this guy is doing here. So for each of this guy, they must we need to check as it's as a what's it called? We have not I don't we not even use this is just a simple stuff, sha, but in a normal app, we want to use it as a serious app. We need to test all those things. We need to check for all those things before we run the tags and all those stuff like that. But just as simple as let's just make it more simple, just simple. No need to modify any something anything hard. Yeah, I guess. So look at this guy now. So this is what this one is doing here. It's just like the task, the component in that task that we want to carry out. So this here, what this will now do, whenever you now add any of these tasks, this one will not be the one to generate the unique ID here. So now you're going to generate it for us. Why this mapping is the one we are using to store each of those tags you put in. So when you put this one in, you're going to store the tags with a unique ID. You get which this unique ID has been generated. This guy will be the one to store it here. Everything will be stored in this what's it called, this variable here. So this part, this unique ID, this one will be mapping, will be keeping track of, okay, we want to cook rice, then okay, we've put in your content and all those things in your function. So this one will now map it. This one will generate the unique ID, and the unique ID has been generated will now be mapping each of the tasks and seeing that okay, it has a unique ID that I can use to identify it. I can use it for what's it called to the contents name as well. Then the is it completed or not. So this what this guy is the storage. So and also we now create an event. So this event is just like for a user. Whenever any event is created, so we should notify us. So that's what this guy is doing here. So initial what's it called constructor. What constructor was doing here is what constructor is doing here is actually to initialize our task counter. The one that we'll be counting in. So we need to initialize with zero, that it starts from zero. No, all what we call as a computer starts from a zeros and one. You only understand zeros and one. So this task counter that will generate a unique ID starting from zero. So we initialize it that okay, it should begin from a zero. Then now we now come here comes to the function for creating the task. So if you want to create a task, we have to write all you just need is to write the name of the task you want to create, like cooking rice. Once you put your cooking rice here, the first thing this guy will do is to update the content you've put, like what's it called, the cooking rice. It's going to update it for you. It's going to add. So if you keep adding it, keep putting it, adding tasks, it's going to be arranging it accordingly, and what's it called, the tags to be generated. So this is how the unique ID will be generated. So you create one task, it's going to generate the first ID for you, which is zero. Okay, it started from zero, so it started from one. If you create another one, it's going to start from two. It's going to follow they will be following suit like that. So you'll be having one, two, three, till depends on, even if it's 100 you created. This guy will be the one that will be keep increasing and arranging it accordingly, ascending order. You get. So why this guy here is the one that is now doing the main logic, is the one creating the tax itself. This one is just increasing the tax, each tax you put. While this one is the one doing the creation. You guess. So let's just explain it now. This is the tax now. This tax now is what? Is the storage, right? Don't forget it's the storage. This storage here, where is it? Yeah, this storage. And what was this guy storing? Don't forget he's storing what? A unique ID. What? He's storing it to map. You get, you are using the unique ID to store each of the tags here, the tags up there, right? So the same thing is happening here. So since tags is this is a unique ID that is storing, which is equals to the the unique ID that is mapping. So we are using it to map these guys. Can you see it here? So the first one we have here is going to check, is he okay? One, if the unique ID is one, then the name of the content that the person puts in input, then at default it should be in false because it's just creating it. It has not completed the task. So that's why it's at default in what as false. So we use this to emit our the events we created. So that's for the now we toggle, then we now have a toggle function. So the toggle function, what it's doing is just to we have our storage and it's keeping track of the unit ID. So it's telling us that the task.complete is equals to is not completed. So what this guy is doing here is that whenever you put, you are just need to cross check. So if you put any of the unique ID here that has been generated, maybe one or two, whatever. So this particular function will be telling us has it been created or has have you done the task or not. There'll be a button that you have to, once you are done with a particular test, you click on yes, I'm done. So this guy will check, will be the one to let us know, to find it out, maybe to check if this guy has been created or not. All you just need to just put your text ID and it's going to tell us that maybe it is completed or not. So what is it making it telling us that? Why is it making it telling us that? What makes it tell us that it has completed is because of this emit function. You get, so this is the one that we emit the event that has been created out there. So an update task, yeah. So update task, as you all know, the update task, how we run it from update task. For example, I've put cooking rice as I explained the other time, I've explained earlier that you put a cooking rice. Like I want to cook rice. Now, maybe you now change your mind. I don't want to put rice again. I want to put, maybe I want to cook beans. So for it, you've created the what's it called already. You've created the task already, and the task has been stored already. Now you want to change it. So this is where we use what we call update. Then you try to what's it called? You try to put this guy. You try to put the unique tax ID, the one you want to change, then you put the contents you want to change, you want to replace with the one that was there before. So this what you are doing with this one. So let's look at it together. So this is the tax itself. That is the tax itself. Then the tax is assigned as a storage. It's just like we're using it as a data type. That this one now, this tax here, this variable tax here should what should be accepting, should be storing this tax, the main tax itself. Get, then we now use the task, now the storage itself, the unique ID should, so all this now, what is storing, should be storing it in our unique ID, that has been created, that is the counter. Then we now use our task dot contents, that is the content of this task. Any contents they put here, the content, the tax dot content. And don't forget this tax here, we have made this is just like saying what's it called, storing normal data. Now if you say uint, yes, uint public, then let's just say my number. So we all know that here now, this variable here, my number, just using as an example, this variable here, my number, it can store is only what will it store? It will only store uint. So this one number, you cannot accept what's it called, variable. The same thing is what we actually doing here. That's what we're actually doing here. So this tax now, we are assigning it to be, is serving as a, don't forget the tax is up there, we have declared it already. So it's service struct now, this tax struct now is serving as a data type to this tax. So definitely this small tax, and this tax with capital letter, with small letter now, is storing whatever that is inside here, is storing it on using what we call storing it permanently. If you use memory now, we know that it's going to store it, what's it called? It's going to store it temporarily, but we want to store it permanently. That's why we are putting the storage. Now we now equal, it should now equal us to the tax, the tax, the forget don't forget the tax that is mapping a unique ID, a unique ID. You get. Then we now, since we have it there, we know this guy now, this tax now has become, has this all this value here. It has become all this value. It has all this value here. So we can we can use any of this guy here now with this guy. Where is it? Yeah, with this guy. So that's why we use tax.content. So whatever content you put in this tax should be stored. Whatever content you put here should be stored inside here. That's what this guy is doing. Then we emit the event, that we create the event already, so we emit the event. Now the next one is to delete our task. We use it to delete the task. So just by putting only the ID, once you put the task ID, then we are good to go. It's going to do the same thing we did the other time. Tags, then storage. We store everything here. Then we use it to equate the counter, the task counter. Then we use the keyword delete to delete task, any task we put here, to delete it from this guy, from the task ID. So that's just it, and we emit our event that we created. So that's just it, and with this you are done with our task, what's it called, our to-do list. Now let's try to um let's save and try to compile. So let's try to compile by using npm. Let me see, do we put anything here? Okay, let's just in a shortcut, let's put compile. Then we put npx hardhat compile. So we can still do the same thing whenever we want to test, so we can use it to test too. So that's how we just use npx hardhat test. So for shortcut, we can also do the same thing for this guy too, deploy too, because we're going to deploy the contract. Then maybe in the next class we're going to do this. We're going to npx hardhat run scripts / deploy.js. So we're going to write a script for this guy. Then after we're going to write a script to deploy our contract for it too. Then after that, we just call it a day. Then we have it. We have another class. We have another video to do the testing as well. Yeah. So having done this, just save. So you don't have to stress yourself. Just do npm run compile, and it's going to compile your contract for you. It's going to compile your contract for you. Yeah, let's wait. Okay, let's go in. Okay, there's a deploy script there already. So let's use another one. Let's use another name for it. Let's quickly change the name in this guy. Let's quickly change the name. So it should have been deploy. Should just be, okay, I'm coming. Let's just so it should just be to do list .js. We'll create the folder too. We'll create the file rather. So let's save. Yeah, so we're having an issue with this. I think it's because, oh, which one is here? Right. Oh, sorry, I'm not in the directory. So this is the directory for this guy. let's quickly direct whatever from this guy. Yeah, so we are in the right directory now. So we're just doing pm run compile to compile our contract. Yeah, let's wait. It's compiling. Yeah, cool. So it has compiled. So but there's a warning, though the warning is not actually what's it called, something serious. Yeah, it's telling us that task story task, so it's not actually something serious. Yeah. So another warning is that we are not putting SPDF, so SPDX license. So let's just do that so that this one you can leave us alone. So the SPDF, what it's just doing is just like um verifying that your contract can be used by any other person. So this storage now, the issue of the storage, okay, I think the guy wants us to use memory instead of storage, but let's just leave it as storage since we're not doing something serious. Let's leave it as storage. So let's run it again. So the SPDF issue will be gone. So it's really giving that guy, and it's not actually an issue. It's not actually an issue. Yeah, it's not actually, see, that one is gone already. So, but it's not actually an issue. Doesn't have anything to do with, because we work with it and nothing will happen. So we'll be able to compile our contract. Now let's quickly deploy. Let's write a script to deploy our contract. Then maybe in the next class we give what's it called? We write a test for contract. So to do list.js. So in our deploy script. Now for our display script, we just write const eaters, then equals to, then what we are doing is we are um trying to import eater.js from our Hardhat at default. Hardhat has an eater.js library already. So okay, yeah, this is the thing we need for now. So the next thing we need is to create an asynchronous function. So it depends on how you want to write it, but I love it writing my asynchronous function this way. So then we'll give it a name. Let's just say main. Then yeah, so that's it. Now the first thing is to set up an account. If you want to deploy your contract, set up an account that will deploy your contract. So setting up accounts. So that's the first step. Then you declare const any name. You can give it any name. Let's say deployer, which is equals to. Then wait. Now we're using an eater.js, right? So you used to call the library eaters.get contract factory. Sorry, dot get signer. So let's call this, yeah, get signers. Yeah, so this will be the one that will get the account that will deploy our contract. So you can just, if you want to print it out to know the account, you the console.log, yeah, deployer, just put dot address so that you can see the address that is deploying our contract. You get. Then, so having done this, wait, let me just, yeah, my battery. So yeah, this is, we're set up our account. Now the next thing is to load our smart contract. So we say to do list equals to wait. Then the next thing is to get the contract factory. So get contract factory, get contract factory. So we want to get the information in our contract. So what's the contract? I think it's to-do list, right? So that's the name of the smart contract. That's all you put here. Let's check it again. What's the name we've given our contract? To-do list, right? Is it this name? Is the one you are putting here? Yeah, this is the one you're putting here. So that's the first thing. Now the next one is to now use you can use small letter, anyone you can give it, you can write the name of contract, so which is equals to await. Then the to-do list contract you get, which is to-do list contract that's uploaded the main contract. So then you use the deploy. Yeah, we have a constructor, but the constructor has been given a value, so you don't have to put anything here. So then we just say const we say console dot log. Then we can use a slash back saying deploying contracts to. So then to do list dot. So this is going to print out the address. And the next thing is to just come here and say main. So in order to save my time, there will be like an what's it called? This guy error handling. So let me see if I can see it here. I'll just pick it from here sharp. Okay, there's no, it's not here. So we can leave it this way too, but it's due to, in case you have any error, you can easily do what's it called? Can easily trace it. So that's actually what the error handling does. So where is it? Where you go? I don't know why it's not showing. Okay, let us leave that. So we can leave it this way too, or better still we use that guy. You get. So with this you can deploy a contract to do list. Now let's quickly check our the deploy script is very well written. Okay, to do list .js, yes, it's pointing at this. So we are deploying. Where are we deploying? Let's quickly check our the guy. So this is it here. So we're actually deploying it on this local hosts on this Ganache blockchain. So that's the network we're using. So what we just need to do, okay, so yeah, I need to specify the network here. So I've not done that, so I need to specify the network. We just say dash network. So dash network, then we say localhost. Yep. So yeah. So with this, I think we're good to go. Okay, so we're good to go. I just save. Also need to write here is just say npm run deploy. Though on a norm, we should test first before we need to test our contract first before we deploy. But I think deploy is just rush the deploy first, then come back to test our contract. Oh, cool. So let's see what's the issue. Yeah, the issue here is that I only use get contract. I never bring in the libraries. So that's why I'm having issue here. So here it should be itas dot get contract address. You get. So in order for it because we are calling from the ita.js library. So using only this method is not enough until we add where we have to tell them where the what is coming from, where the get contract factory is coming from. So that's how we're having that here. So let's run it again. Yeah, okay. So what's the error again? Is there insufficient fault for intrinsic transaction cost? What could that be the issue? So here now the issue here is actually the this guy is actually the value here. Let me see. Yeah, okay. I've seen where the issue is. Like, so we need to change this guy. Need to change it. I think it's this server. Okay, server here. This needs to be changed to 1337. And then we save. Yeah, cool. So I think it should work now. So the chain ID we were using there before was not the same. So that's how we're having that issue. So yeah, I hope it should work now. So I'm using Ganache. If you use normal or what they call, yeah, okay. What is this again? Nations network error new message. So let's check where are we having that issue. Provider error. Same provider error. Okay. Okay, let's use this guy instead. Let's use Gauli instead. Let's use Gauli. Let me quickly copy the setup of Gauli here. Where is the setup? Quickly copy the setup of Gauli here so we don't have to stress ourselves. Yeah. I think this is the latest. The yeah, this is the reason why it's not working. You don't need to even use Gauli. You should use this too. So this is not the what in a Ganache, it is just a temporary account. Whenever you stop using it, it's not gonna work anymore. So this is the latest one we're using now. Look at it here. This is the latest guy we're using. Let me even copy it like that. So this is the latest PK, that is your private key. And also, mind you should not expose your private key like this. There's a way you have to encrypt your private key, you get. So maybe in our next class, in our next class on testing, we'll talk about how to make our private key secure, like unlike putting it like exposing it like this. Please don't expose your private key like this. Your real fund. If you expose it and you see it, it's gone. Gonna be it's gone. You get. So yeah, hopefully it should work now. Yeah, hopefully it should work. Oh, sorry, we don't have. I don't even have. What's it called? Too. I'm not on. Okay, it didn't work. Yeah, it works fine. Cool. You see, it works. So we deploy our contract. So this guy is not showing, but what we actually after is this. So our contract deployed successfully. So that means that we can deploy your contract and have your what's it called and use it for whatever you want to use it for. So in our next class, we're gonna be what's it called? We're gonna be having this guy. We're gonna be testing the contracts. You guys are gonna be testing our contract and add some more meaningful stuff to it as well. All right. Please keep subscribing to this to the YouTube to my YouTube channel. Send it to everyone, and then if you want to learn smart contracts, you want to know how to write smart contracts, yeah, like and subscribe to my channel. Thank you.